Today we're talking about predicting products. Now, you know how to identify the reaction type, you know how to balance chemical reactions. You've been doing that for a while already. So predicting products becomes a natural progression of what we do for that. So we want to know where we need to start from. And hopefully this is no big surprise, but I want to say it anyway. So you need to understand your reaction types. You need to have a good handle on that. And there are basically 5 types of reactions that are going to be important. One is synthesis, decomposition, single displacement, double displacement, and combustion. Understanding or recognizing the pattern in those reactions, particularly the pattern in the reactants, the left-hand side of the reaction, that is going to be a really, really important place for us to start. The second thing is when you're only given the reactants, you need to then identify what kind of reaction is it likely going to be, and then understanding the pattern for that. So understanding that those general formulas in the previous page, if you can recognize, hey, it's going to be this kind of reaction based on the reactants, then you can predict the likely products based on that overall pattern. And then we're also going to make a lot of use out of nomenclature. Particularly our first couple sessions of nomenclature with metals and non-metals. Not entirely, or not exclusively I should say, but that's going to be a really important player for us. So make sure you're whatever you want to call it, make sure you're all up to date on your nomenclature. So we're going to start with this. And this is sort of a typical kind of question that you're going to be given. You're going to be given 2 reactants or 3 reactants or some reactants and asked what kind of what are the products of that likely going to be? Well, if you look at that, there's only so many options that you have when you have 2 elements, aluminum and oxygen. So that's likely going to be a synthesis reaction. Now you could call it a combustion reaction because you are reacting with oxygen. But either way, we have a pretty limited amount of possibilities. So if you want to think of it as a combustion reaction where the products are going to be the common oxides, or if you want to think of it as a synthesis reaction where you're going to be making a compound of aluminum oxide, next question is, what's the formula for aluminum oxide? Well, then that takes us back to nomenclature. Aluminum is always +3 in compounds and oxygen is always 2- in compounds. At which point, what's the formula for our products but aluminum oxide there? Now at this point, if you were to leave it just as the products have been predicted, I would be perfectly happy. If you want to balance them and that helps you out, make sure that everything fits in spots for you, totally fine. But generally speaking, when I ask you to predict the products, all I'm looking for is you predicting the products. Balancing is an additional step that often isn't necessary. What if I had this one? Well, now I've got a mercury and oxygen compound, and that's it. That's all I've got there. So my options for what kind of reaction that's going to be, again, are pretty limited. It's likely going to be a decomposition, where I take that mercury and oxygen compound and break it down into its components. When I'm doing that, nomenclature again, I have to remember that oxygen breaks in its elemental form is a diatomic element, at which point mercury 2 oxide in this case breaks down to mercury and oxygen, where mercury exists as a single atom element and oxygen is a diatomic element. Now again, you could balance it. You don't generally need to unless you're specifically told make sure that you balance this, but if I were to balance it, then that's what I would need, 2 in front of the reactant and 2 in front of the mercury as a product. This reaction. Well, this reaction I have an element with a compound, a metal-nonmetal compound, and when I go back and I look at the general formulas for chemical reactions, that's probably going to be a single displacement, where I have an element reacting with a compound, producing an element and a compound, where the 2 metals have traded places. Not always the 2 metals, but in this case I've got a metal and a metal-nonmetal compound, so in this case the 2 metals are going to trade places. At which point I need to be thinking about nomenclature again, because magnesium is always 2+ in compounds, chlorine is always 1- in compounds, so if I'm going to have a compound with magnesium and chlorine, what's it going to be? It's going to be that. And this is where it gets really, really key, because the formula for iron 3 chloride and the formula for magnesium chloride are similar, but they're different. They're different because of, well, not because of nomenclature, but that's the skill we're going to turn to help us predict the products. Doesn't need to be balanced in most cases, but if you did want to balance it, then it's good practice. Then it would be balanced out like that. If I had this compound, now I'll walk through this and then I'll pause and go back. So I have this one here. So a sodium sulfide and a gallium chloride. Compound with a compound, so a metal nonmetal compound with a metal nonmetal compound, it's probably going to be a double displacement reaction, at which point the two metals again are going to trade places. But now I need to be thinking about what those compound formulas are going to be, because sodium is always 1+, gallium is always 3+ in compounds, and then I can say something similar with sulfur and chlorine, and their charges when they're with metals, at which point then my chemical formulas need to be consistent with nomenclature. Right? If I'm going to have sodium with chlorine, what's the formula going to be? And I have that. Again, if you want to balance it, you can certainly balance it for extra practice. Probably not for extra marks unless you're specifically told in the question these need to be balanced. Okay, I want to pause here for a second, because at this point where we are at in our nomenclature, there are a lot of compounds that we cannot easily do. We haven't done the nomenclature for, but we can still do the predicting products if we know sort of a one look ahead at our nomenclature in terms of what the charges are going to be. As soon as I know the charges on something, I can do this or the single displacement one because I have enough information. There are other elements where if we were given a bit more information about the charges, then we'd be able to do that. But I'm going to try and limit ourselves initially anyhow to what we have done with the nomenclature, but as we've added more, we will be expanding our ability to predict products. In a chemical reaction like this, where one of my reactants is oxygen, automatically it could be considered a combustion. Some reactions could be considered something else. Think back to the one with aluminum and oxygen. We treated that as a synthesis. This one, the only thing I can do is a combustion. But that's almost easier because at that point, the products are the common oxides. And in most cases, the common oxides or the products are going to be carbon dioxide and water, which makes predicting the products really easy. Carbon dioxide and water. The only thing that can change is if that reactant there with the carbon, if I threw in a sulfur or a nitrogen, but I don't really need to do that at this point. I can maybe see myself doing that in terms of balancing reactions, but not so much in terms of predicting products. But if we did, or if I did, then you'd have to figure out what the common oxide of sulfur is, what the common oxide of nitrogen, or things like that. So it's still not incredibly difficult. It just means we need to add one more piece to it. And again, like the previous ones, it doesn't need to be balanced, but if you choose to balance it, then that's totally fine. It's excellent practice. As a couple of tips. For when we're balancing products right now, you might predict something that makes sense but isn't actually correct. So for example, if I asked you to predict the products for this one, which is a decomposition reaction, if you came up with something that was sensible, I'm going to accept it. If you were to actually find the products for this one, do this reaction for real and look at the products, you would end up with the products that you see here, and we haven't necessarily done all the nomenclature, so I'm not going to say them, but you might not have predicted that. That's okay. It does need to make sense though. So if you end up writing the products of something where your atom of sodium has to have a charge of 5+, well, that's not possible, so it's not sensible. I'm going to be working with things that you can do. I wouldn't give you a question that you can't do. I mean, that just doesn't make sense. What's the point of that? So understand that anything you see is something that you are able to do. Maybe not super obvious. Maybe you're going to need to know one or two more pieces of information. Probably not two. But you will be able to answer any of the questions you're given. And as I've been saying a couple times repeatedly over and over, you don't need to balance those reactions. Some people do find that simpler, because if it balances out, then everything looks right. And sometimes our initial prediction isn't balanced, and then it feels like I'm missing something just because I've got chlorines unaccounted for or something like that. That brings us to the end of this. And balancing products, or not balancing, rather predicting products, is a big enough thing on its own. but it's also follows or uses patterns that we've already made use of. So it's just a matter of bringing a couple of things together. It's not all that difficult. It's just pulling in a few pieces of knowledge that you already have. Anyway, good luck with it, and I'll talk to you another time.